Here you go. Yeah, I wanted to just show this as part of it.
Have you been pleased with the audio quality of the videos? Have they met your expectations?
Yeah, they're
without
pretty good.
having to do the mic? Okay.
We did do the mic a few times,
Yeah.
but and I liked it when we did.
I wish. Actually, I'll have to get the new version of this. Because the problem here is that the way the USB identifier works, it doesn't allow you to select two of them at the same time. If you plug in two, you only can use one. But there's a new version that just came out that's USB-C and probably has no other features other than the plastic is different. And, yeah. Okay, cool. Yeah.
One more second. I gotta find this one paper.
We'll go around and do introductions real quick. I'll try to do it quick. So, I'm AJ. Most of you know me. My company is Root. We now are certified and authorized resellers of Proxmox. Also do Go and Node. And one day, I hope to be able to do Zig professionally as well. And I want to welcome you all to the meetup tonight.
My name is John. I like to dabble in a lot of things. I've got a master's in linguistics. I teach unique Python classes really. I tutor math online. And I'm private to Mexico. Yeah. For a while. So, I have to study.
My name's Robert, and I'm a fiber technician.
Sorry. I'm Matthew Madsen, his son, mainly here for the food, but it's also a good time for me just to catch up on reading. So.
That's fair.
I'm Matthew Madsen, and I'm a mathematician pretending to be a software engineer. And
That's the best kind.
but I'm not entirely sure if I have interest in Zig or Rust, but since my interest tends to apply in the ways of things like Common Lisp and Forth and Learned, not many meetups for those things. I figured that it's fun to come to these other ones instead.
I'm Steve Brown. I am trying to make a career shift into computer science related. I like back-end related things, and so I am trying to learn more about lower level languages.
I'm Travis Barney. I work here at v0.14. I'm primarily a front-end developer and try to dabble in full stack, but mostly client-side stuff. So I'm just here to help keep the doors open.
And we'll let you introduce yourself in just a moment, but first, a brief message from our sponsor. Once again, welcome everybody. I'm going to take the countdown out for our like one online viewer here. So
It's my one fan.
yes, you're one fan. Welcome everybody to Utah Zig. Thanks for coming out tonight. Thank you to v0.14 for providing the space and the pizza. Thank you to Root for doing the meetup thing. And thank you to Niles for presenting tonight for us on Zig version 0.14. With that, Niles, I will turn the time over to you.
All right, well, thank you. Yeah, my name is Niles Salter. As he said, my website actually is validark.dev. I just got that domain, so that's kind of fun. I have some older articles here and my presentation slides. On the suggestion of AJ, I actually did not spend 2 months making this presentation. So
Don't help me now. Now when it sucks, people are like, oh, you only spent a month doing this.
yeah. So I actually didn't make slides for this one because there's a video I want to show which covers most of the stuff that I want to go over. But this is the 0.14 release notes. and it represents 9 months of work from 251 different contributors. That's 3,467 comments. Commits. And there is a whole bunch of stuff in here. And I want to start out by watching this video. So there is an AI voice, so trigger warning if that bothers you. But
First trigger warning, is the audio set to go out?
Tell
on
you
HDMI?
about recent changes in
It's on my
Zig
computer.
0.14.
Can people hear that?
Sorry for AI voice. I'm not a good speaker myself. So, there are new features and changes
I would recommend
in
taking
no
a moment
particular.
to switch the audio to the HDMI audio out. Because to me, that is difficult to
okay,
hear, and I'm right next to it.
okay. Sorry. Sorry, what am I looking at? Oh yeah, let's do that one. Can I make it the default or something?
Oh, check the button.
Set as default. There we go.
Interesting.
Okay, let's try it.
And then we may need to hit the volume button on this
I'm
thing.
here to tell you about recent changes in Zig 0.14. Sorry for AI voice. I'm not a good well, hi there. I'm here to tell you about recent changes in Zig 0.14. Sorry for AI voice. I'm not a good speaker myself. So, there are new features and changes in no particular order. In the allocator interface V table, we got a new method, remap. Now we can ask the allocator to expand or shrink a memory block with possible reallocation. Here's the signature. Okay, this one is my favorite. New branch hint built-in function allows giving a hint to the compiler about possible branch frequency. Its arguments can be likely for branches that are expected to be taken most of the time. Unlikely for branches that are expected to be taken rarely. Cold for branches that are expected to almost never be taken.
Yeah, I think we got the point of that one.
And unpredictable for branches that we expect to be.
So I actually use this one quite frequently. That may be unsurprising. In my code, you can use this to massage the assembly output, where you say, okay, for my Tokenizer project that people know about, I check, are there any non-ASCII characters? And in the unlikely event that there are, then I go off to some cold code. But for the majority of source code that I'm tokenizing, there's no ASCII characters. And so typically I don't have to handle it. All I have to check is make sure that I don't have to handle it. So that sort of thing can be useful. That's what I use branch hint for. Yeah.
Hard for the branch predictor, so the compiler can put in extra work to try and make this code branchless. Okay, this one is just a little.
Yeah, I don't know if that's actually true, that it will work extra hard to make it branchless. It's more like it influences where the branches will appear in the assembly. So, yeah.
Bug fix, but an interesting one. So, in the following code, we can see a bar function getting some value as an argument. This value is a block, increasing the foo variable by 1. And we expect it to be computed just once, so the final compile log should print 1. But in previous Zig versions, it was printing 2 because of a bug. In newer version, everything is okay. Now, a feature I like.
Just for the record, that was a comp time issue, so it was not a runtime issue. But yes, there have been a lot of comp time improvements.
We can declare dicta literals and structs representing any constant values. For example, it could be a default value, and we could refer to it like an enum literal. Could be useful for my chess engine. Next one is a new.
Yeah, so this one actually is kind of a big change in my opinion. What this is for, basically all of the objects in the standard library now have special fields like this. So this is how it would be declared. You have some struct, you have some data, and you have a constant that just like lives inside of the struct as like a namespace thing. It's not necessarily realized at runtime, or it's definitely not. And so what this is doing is it's based off of this type of S, it infers that it should look inside of S for the member.default, and that's here. And what this is used for now is all of the standard data structures. This is a more blessed way of declaring it than just using the dot and open and close curly braces. And the rationale behind this is that, you know, I actually probably have it right here. Not this one. Yeah, so these are called decal literals. Let's see if I can zoom a little.
Yeah, please should.
And the rationale behind this is to avoid faulty default field values. So in some structures, there are a bunch of defaults set for the different fields. And those oftentimes can be related, where it's like, okay, so now you can like have different default structures. You could have an empty one, or you could have one that is initialized for different use cases, because yeah, if there are members that implicitly have some associations, what you wouldn't want is someone to use this syntax, but then they just put a length in here, when you shouldn't just set the length, you have to set the pointer. And so avoiding this kind of initialization, especially for more complicated structures where you have several choices of like what the default object should start out as, when there's an implicit relationship between the fields, this can be helpful to avoid bugs where someone, maybe they only declare a single one of the fields, when implicitly, when you do this, you should be doing something else. So that's the rationale on that one. I think that it's mostly a good idea. I feel like it's a little bit redundant for things like an array list, because I'm not going to mess up an array. But yeah, if it's something more complicated where you have a number of fields and they have some connections in the contract of what the data structure is doing, then it makes sense to me you would want multiple different default options to choose from. Another interesting syntax, I don't know if he's going to show this here. Let's see, what's the next one?
Next one is a new built-in function field type, as the name suggests.
Okay, that's just a nice feature. But yeah, so now we have this syntax here. So Zig can now infer this init capacity is supposed to be this type buffer, and that's okay.
Time for system update? What?
My screen just flashed, and then that one turned off. All right, so let me turn that off, and then let me look.
Plug it back in.
Yeah. Honestly, might have messed up an update. I'm just gonna restart my computer real quick.
Is that new feature of Arch?
Yeah, new
It's got the
feature.
Windows updates going. Are we in presentation mode? Want to restart? Let me help with that.
For real. Okay. Let's actually unplug it for a second, so it's gonna show my password.
Oh, and we've got quite the online cohort as well.
Oh, there you go.
I forgot to post it in the Zig channel, but we got 3 people tuning in. Just having a little technical difficulties, folks.
Sorry,
Out of the
everybody.
ordinary.
Okay, we're back. Okay, so yeah, it's a cool little syntactic nicety. It will now infer that this .init capacity should come from this buffer type, which is declared here. And yeah, it's even recursively doing this on the allocator, so, or no, on array list. So data is this array list. It's saying dot data equals try dot init capacity. So dot init capacity exception is happening. Pretty cool, I guess. This actually really tripped me up the first time I saw it. I'm like, is that legal Zig syntax? I didn't see the update when it came out in a nightly. So this was one of the ones that actually blindsided me when I saw it in someone else's code.
Will you go back to that for just a second?
Yep.
I was just a little confused here. Init capacity, allocator capacity, try data equals. Pardon me, but how does that make sense?
So the dot init capacity is pulling that method from the type that the destination will be.
Which is buffer, right? I guess I don't.
Yeah, so-
I'm a
so
little
right-
confused as to how this is not recursive.
So right here, it's
That I
doing
understand.
buffer.init capacity,
That's
which is
perfectly
this.
clear.
In here, it's pulling the type of this dot init capacity, which is array list.
Oh, okay, so array list. So init capacity is a convention
Yeah, at least for array list.
and buffer.
Yeah.
Okay.
Well, yeah, this is just.
Okay, now I understand. I was confused. I was thinking it was calling itself recursively then.
So yeah, it's kind of cool. I guess it's nice. It feels a little bit like Kotlin stripping away the 3 declarations that you need in Java to do anything, down to just 1 or 2. But yeah, so it's a little nicety.
This course is about systems and system thinking. We use system.
Well,
I'm on Firefox because my Brave doesn't scale properly on my OS. So
transfers.
yeah.
Bar function increase version of any.
I appreciate your excusing yourself for having that.
Now, a feature I like. We can declare literals struct defaultable for my chess engine. Next one is a new built-in function field type. As the name suggests, it allows us to get the type of a struct field at compile time. Simple, but useful. Another little change.
Yeah, you could do this before, obviously, but this is just a super convenient way of doing it.
Now, we can get the address of a variable before it has been declared. This allows us to create cyclic or self-referential data structures.
Just for the record, this is for a global constant, like compile time. So this is not a runtime feature because Zig did not invent magic, but yes, you can do this now.
I guess it's the first time I see fuzzing in the standard library, but here it is. It's pretty simple for now, no fancy type-based generation or anything, just a single function fuzz input for now, but I expect it to grow in the future.
Yeah, Zig has a lot of interesting facilities for fuzzing. Another cool thing that it can do, if you haven't seen it before, is there's a special allocator you can use where it will fail on the nth number of allocations. And so what you can do is you can run your program and you can test if it'll work when you fail on each of the allocation stages that could happen. And so yeah, it's a really cool. The Zig standard library has a couple of really cool facilities like that.
Okay, I found out this one is a very controversial one. So, if we label a switch statement, after that we can use continue with that label and a value to jump to a specific branch, something very close to a controlled go-to. In the code example, on the switch statement, we first jump into the first branch, then into the second branch with a continue statement, then into the third branch, and return after, passing the test. I'm not a big fan of this feature, since I feel like Zig's style is to avoid unnecessary complexity in features, but here they are. I just hope it's really useful for someone.
Do you have any opinions on that?
Yeah. In general, I like that it makes it more succinct what you could do before. So what you could do before is you could have a while loop and the switch goes inside of it. And let's say you switch on variable x, and you could say x equals 2, and then let the while loop take you back in the switch. However, LLVM cannot optimize that to this, which is really upsetting, actually. It was actually the first assembly that I looked at fell apart on these grounds that this solves. And yeah, so part of it is it does look nicer. You don't need a while loop to wrap it. And yeah, I like that Zig has like a safe go-to, safe as in like you have to jump to a block, so you don't have the traditional issue of like uninitialized variables or things like that. And it makes it nice to express the exact control flow that you want. And yeah, today it will also let you get the compiler emit that you want out of LLVM. And the only other way that you could get the same effect as this is with tail calls. Does anyone know what that is? It comes up a lot in scripting languages or functional languages. So tail calls is where at the very end of a function you return the result of a function. And so typically when you call a function, the return address has to go on the stack. When you call another function, that return address goes on the stack. You execute that code, you look at the return address and jump back, and then when we're returning, we look at the return address and we jump back again. With tail call elimination, this is an optimization where when we know, or when the compiler knows that we're at the very end of a block, we're returning the result of a new function, instead of just writing the new address onto the stack, we overwrite the previous address because we know we don't have to come back to the function just to return from it. And so we can avoid a return. So anyway, so that is a mechanism you can use to get arbitrary control flow. But if you have a bunch of variables, it makes it very cumbersome to express it that way, whereas this is a very succinct, clean way of doing it, which is the way that I would want to express it. And this came up for me in one of the first projects that I did for Zig. Not for Zig, but I did in Zig. And yeah, some people may know, but I made a dynamic score decompose try structure. And yeah, the first thing I did was, I show like, oh, if you have a try, you can sort it horizontally to speed up autocomplete queries that are scored. So there's a number associated with each one. You want the highest one. And then I show you can decompose the tree and you can sort vertically. So let me just drag this over here. And draw in an LCRS form. When we do the same query that we did before, significantly shorter. But anyway, so it happens that the control flow for this, it couldn't be expressed in Zig at the time that I wanted to write this without like LLVM messing up the optimizations. So yeah, so for me it's really nice to have this labeled switch. Let me go back. Where's my thing here? Yeah. For me, this is a really nice feature. I like this. I have this paper here. This is called Real Programmers Don't Use Pascal. And I just read this the other day. It's talking about the good old days, the golden era of computers. It was easy to separate the men from the boys, sometimes called real men and quiche eaters in the literature. And yeah, basically it refers to Dijkstra, the person who wrote Go To Considered Harmful. It refers to him as a quiche eater. So, and this is a paper, so it must be right. So, anyway.
When was it written?
I just thought that was funny. Looks like 1982.
So it was right when it was written.
Yeah. So, yeah, real programmers aren't afraid to use go-tos. Real programmers can write 5-page long do loops without getting confused. Real programmers enjoy arithmetic if statements because they make the code more interesting.
I love that they're measuring code size in pages.
Yeah. They can write self-modifying code, especially if it saves them 20 nanoseconds in the middle of a tight loop. They don't need comments. The code is obvious. Since Fortran doesn't have a structured if, repeat until, or case statement, real programmers don't have to worry about not using them. Besides, they can be simulated when necessary using assigned go-tos. So yeah, it's a pretty funny paper. It's not that long, but yeah, pretty cool.
So that sounds sarcastic. Was the meaning for it to be sarcastic? Because there's a lot of functional languages that actually do all that stuff.
I mean, I think like anything, it's partially real and partially meant to be humorous. I mean, the term quiche eaters is pretty funny to me, so that's how I interpret it anyways.
I just hope it's really useful for someone. Okay, another bug fix.
Oh, wait, I have one question.
Yeah.
If I may. So, with that continue, can the example is shortened, but we can do operations in that block. Continue to something else, do operations in that block. Continue to something else, do operations in that block. So that feels like a new paradigm of programming that I am not familiar with. That's because I go to, but it's within the scope. So you could actually have an infinite loop inside of a switch.
You could.
That sounds like a new type of dangerous. Real programmers can handle it.
Real programmers are fine with that. In my older Tokenizer, you can see I have a lot of test files that I don't put on GitHub.
So how would you deploy code at NASA that has that in there, where it's a requirement that you have to be able to deterministically say that the program will halt?
Well, I'm less strict than NASA.
Okay.
So.
Could you increment I guess you could increment a counter that's in that scope. And so you could just check.
Yeah.
That would defeat the purpose of the optimization. You wouldn't use that in NASA, period. Yeah.
Have you ever heard of Duff's device?
What?
Duff's device?
No.
Was it in this one? It's not in this one. Maybe I just say Duff device. Okay. Here we go. So this was the issue to introduce it. And yeah, the go-to keyword was removed, but this is how it could be used in their version of going over the abstract syntax tree. Okay. Yeah, this is talking about what I was talking about. Can LVM do the optimization? I guess in one case, he found a way to make it do it. It was by adding a .end. I actually recall reading this. Okay. So.
But if it's not that useful for humans and Zig is for the user, should we be adding features to the language to work around a compiler bug?
I think it is a nice feature. I actually do like using it, and I'll show you in my code why and how I use it. But I wanted to show you Duff's device, and it should be right down here. I'm gonna do Control F. Seriously, man? I searched for Duff, so it should be in here. Is there a more? Oh, go back. Load more.
Ooh.
See if there's another one. Okay. There we go. Okay. Duff's device. So this is a cool one. Let me full screen this a little bit. And we can go back. We can zoom this way. Okay, so what's cool about this is you have some count. This will be some number of times that you want to run a loop. And you actually switch on how many are left. You say modulo 8. So you can do, let's say, so we're unrolling by a factor of 8 effectively. And so yeah, so let's say we have 15 left. First thing we'll do is we'll jump to 7. And we're going to do this bit of work here, and we can continue to block 6. So this gives you a way of following through the blocks. You do the block 6, you follow through to 5, 4, 3, 2, 1, and you can go back to 0. And so what this looks like is you have some, let's say you have an instruction that's some work you want to do. You unroll it 8 times, and you jump to the one corresponding to the modulo 8 at the start. So the first time that we go through, if we have 15 to do, we're going to jump over that first one, go through, and then once we're in that loop, yeah, this is Duff's device. Let me see. This is originally what it looked like in C. Less cool. And with this proposal, oops, we can actually do it like this. So you can actually condense all those switch cases and define it in this way. Let me see if I can show something else to show you what this is. I'm hoping, yeah, so here, so think of it like this. So you have this while loop here, and the idea is you can jump to a specific one of these.
Yeah.
So that when you loop back around, it'll help. So that's Duff's device. It's a really cool thing. It's not used as much nowadays.
I don't know the case where I would use it. I understand what it is practically. I don't know the case where I'd use it. Perhaps that's just because I've never had the opportunity to have it before, but I understand what you mean by unrolling. I understand what you mean by you're going to jump somewhere specific so that it can be unrolled.
Yeah.
Does anybody else have a question on that or understand that? I understand. Okay.
Is there a common use case for that?
Originally, it was an optimization. It's faster. It's a way of doing loop unrolling. It was used in 1983 at Lucasfilm to speed up a real-time animation program. It reduces the overhead of conditional branching. I haven't personally done this exact thing before, but I could imagine, like, if you had a non-SIMD machine, this would make sense. But on a SIMD machine, I think it's less useful. There could be a case where you would still do it, but it's not used as much.
So essentially what we're talking about is rather than dropping down to assembly for an optimization, you can write the optimization in the programming language itself.
Mm-hmm.
Okay, I get that. I am a little fearful of the introduction of so much meta-programming, though, like the idea of unrolling a switch statement inside of itself that you just showed with the 0.7 and then meta-referencing what stage of the switch it is.
Yeah. Where was I? Over here. This one.
Yeah.
Yeah, I mean, it's cool. I mean, I don't know how much this specific thing is going to be used anyways, so I don't think that we have to worry about this specific thing, but yeah, I mean, I think this is cool. I personally wouldn't prefer it in most situations, and I do a lot of optimization situations. I haven't done this before. This has never sprung to mind as something I would do. But it's a cool idea. It's a cool concept. I wanted to show in my code, this is actually an updated version of my older tokenizer that I gave 2 talks on here. And I have an enum. I actually can declare it anonymously here, which is kind of fun. yeah, I have an enum of the different states of this switch loop, and I start out in produce bit strings. So I jump down here, and I produce the bit strings. It looks kind of dirty because I have optimal code on ARM, RISC-V, without vectors, as well as x86. So I had to like do some dumb things to try to make it look even this good, but not the way I would. It's not the idealized code that I showed in my talk, but we need to get the compiler better in order to accomplish that. But yeah, so I produce these bit strings, and then I go to slurp continuation chars, which is just right here. But the reason why I didn't just make this one is because you can enter this from another place, I believe. Yep. And so then what this does is it finds what I call the misalignment. So where we are in the file. So cur.pointer, I take the bottom 6 bits, and then I take the bit string that we're interested in, and I shift it so that the bits that we're interested in are at the start. I do the not, I do the count trailing 0, and then we go to increment the bitmap index, and it's right here. And then, yeah, we either go to check alignment, or we might go back and produce more bit strings if we ran off the end of the chunk. And so let's say we go to check alignment, and this one checks, yeah, this one checks if we have to do this. So anyways, this is what I use it for, is you can have these different states. I have one for checking end of file, one for writing out the token, and yeah, I have some keyword classification here that's, yeah, and I have some artifacts of like the different implementations I tried in this actually. And I have my SIMD and SWAR version. So anyways, that's what I use it for. So I have a number of states that I might be in, and I can at any time just say, now I want to go do that, now I want to go do that. It's kind of like I was talking about a function call, you know, having those tail calls, except I don't have to mess with all of the different variables I want to pass between if I made them different functions. And so for me, this is a dramatic simplification. And when this landed, you know, as far as making it better for LLVM to compile, this code did get a little bit faster. It was already about as fast as it could go. So it wasn't that big of an improvement. But for the mainline tokenizer that Zig is using right now, they got a lot faster. Like, I don't remember the exact percentage, but it was substantial. It was like 60% or something. There's actually the pull request that we could look at if we wanted to. But anyways, that's my opinion on it. I like it. I've used it. It's good for expressing what you want as well as getting the compiler to give you what you want. So I think it's a positive addition. So. Is it on?
Okay, another bug fix. In previous versions of Zig, we could run the following code, putting bar error value into the.
Is this,
And this code will not compile.
Oh my gosh.
Now, we cannot define two different things.
It's still going on my computer though.
The following code will not
let's just
compile.
unplug and replug over here.
All right.
Just unplug this. I got it. Replug. It's still green. Okay.
Let's try mine.
I will be very surprised if the end of the cable being unplugged matters, but
Well,
could be.
Mm-hmm.
Enable disable display.
yeah, let me check on that.
Stop restart moving.
Because you have a fancy computer.
But the good news is, when Zig releases 1.0, we can rewrite Linux in Zig because the Rust port won't even really be started in earnest, and then we won't have this problem anymore. And we can all switch from Windows and Mac to Linux.
There you go. Yeah, I started having instability when watching a video with the latest update that I did. So I'm gonna see if it turns back on when I restart again. There you go. Okay, I'm gonna try a different browser. I'll go into Brave now. Give it
First
a
rule of
Firefox.
computers, never update.
I know. Unplug it for a sec.
You're typing on this side. We can see.
Oh yeah.
Your screen is mirrored. Yeah.
There you go.
Now I won't know how many characters his password is.
Well, he might need to actually see his password and type it. You don't know. I always get worried that people are going to know what I'm typing from the cadence of how I type. I mean, once you know I'm a Dvorak user and you see where the stop, pause, you just count the milliseconds. Yeah, the NSA's technology can totally reverse that. No question.
I used to work too.
Hey, Dvorak, brother. Do you wish that you hadn't, or do you love that you do?
You know, I haven't done like a real scientific study, but I'm pretty sure, because I worked at a text program, that I could take really fast notes before the next call. And I think, and that was when I did QWERTY, and I think I was faster in QWERTY because of that job. But I bet if I went back to a job like that, I would.
Well, is okay.
But I don't think I'm as fast as I was. But
There are two life choices that I question. One is switching to Dvorak. It was necessary at the time for WizPay because I didn't have a trackpad yet, and I was not yet aware that Mac was a thing. In fact, I don't think Mac was a thing yet, or they were in their dark ages.
even with this one,
Just like a trackpad that works. Like I even bought like that $200 Logitech trackpad, and it is. Well, I could never get it working because it's like a 5 GB driver installer, and then
I feel
doesn't do anything.
I'm glad I switched.
But I wish I could go back to QWERTY. Just to use it on
These
my
styles
voice.
avoid unnecessary complexity and features, but here they are. I just hope it's a real bug fix. In previous versions of Zig, we could run the following code, putting var error value into the first variable, which shouldn't support it. So it's fixed now, and this code will not compile.
Whoa.
Yay.
Now, we cannot define two different things with the same name. The following code will not compile anymore. For packed structs, now we can compare them using the equality operator without converting them first. Not a big deal, but nice to have it.
Yeah, I think that's really cool.
Okay, this
A lot of emulator people are gonna like that.
In the past, we could use the compile time known value of page size. Now we cannot, since it's a runtime value, but we at least have minimum and maximum values at compile time. For runtime value, there is a new function, page size.
Does everyone know what that is? What this is talking about?
I don't know why it's a runtime value. So maybe I don't.
Is this related to, on Linux, there's a kernel parameter that's specifically for database optimizations to control, what do they call it, like thunder pages or
Huge pages?
thick pages, huge pages.
Yeah.
Huge pages. That's
So
what
that
this
is
for?
that's related.
Okay.
But this is actually a hardware feature.
Okay.
So not just at the operating system level. The operating system does have to support it, but yes, CPUs, they support a number of page sizes. On x86, the smallest one is 4K. I believe on your ARM it would be 16K, and you can turn that up. Yeah, it has to do with the internals of a pointer. So on x86, before the most recent one, you had 48 bits of actual pointer, and the upper 16 bits were just signed. And the way that it was divvied up is you had the memory that was into the bottom page. So what would that be? 12 bits for this? Yep, 12 bits for this. And then you had 4 sections of 9 bits that would look up into the page tables. And so like the first pages in memory, they specify, yeah, they help specify how memory should be mapped. Anyways, the point is, the huge table thing is a setting in the hardware where it will make it use not just the bottom bits for the page, for the index into a page, because whenever you access memory, you're indexing into some page, and the operating system provides the solution to you. Yeah, anyways, so what you can do is you can like take those 9 bits that were for the first layer, and it will combine it with the page index bits, and so you get 21 bits, and that's why you get 2 megabyte huge page tables on x86. I don't know what it is on ARM specifically, but yeah, similar idea. We can look at the page size. Oh yeah, let's go to Ziglang. Docs. So go to the standard library. SCD docs. What was it? Heap. Right here. So this will query the page size, and it doesn't know where that one is. Let's open the source. That's all right. Real programmers just look at the source. We don't need documentation.
That's right.
Only quiche eaters need documentation.
You know, I love me some quiche.
I'll full screen it so it's not partially transparent. Okay. Let's see if we have queried page size in here. So yeah, there is a way of querying the operating system, it looks like. Oh, it's in scd.options. Let's go to that. We're back in heap. That's not what I wanted. That's heap. I literally clicked on a heap one, didn't I? Amazing. Okay, so this is default. Okay, so we were looking at the right thing. So yeah, on Linux, we check if we're linking libc. We can do std.c.sysconf. Otherwise, we'll just use the Linux get auxval. So, I don't know. I guess you can query. I'm not sure. I'm not sure how much your page size actually changes, or if it's just asking for the default one, because you actually can make it so the default is a huge one. If you look on my machine, I have a thing here. I'm using a lot of memory by default because I turned it all the way up to use exclusively huge pages almost. So let's actually go to this one. Sorry. There you go. Sorry, I don't have the keybinds memorized on this. Yeah, so anyways, I thought it was going to show me the huge pages in here, but it's not. There's a way of doing it by looking at a specific file, because everything's a file. That's Unix for you, but anyways.
There is a new function, page size. In the standard library, we have a lot of renames to make it follow the Zig style guide. For example, in this code, enum values of type info are renamed from title case to snake case. There are a lot of renames, but migration should be straightforward. More in...
Yeah, for me, I don't think this was like a super necessary update. I guess people feel like it's more consistent, but it means that the enums that represent keywords in the language, you now have to use this escape syntax. So I'm like, I don't know. It's okay. I guess I don't have a strong preference for either of these. Maybe I would prefer this, but if it was already like this, I guess I wouldn't mind that either. So I guess it's just preference.
Migration should be straightforward.
And this is just for the default type info
More in the
fields.
standard library. There are 2 new allocators. First, the debug allocator. It's a rewritten version of general purpose allocator with support for runtime page size discussed earlier. It now makes fewer active mappings, so we're getting...
By the way, Andrew Kelly has apologized to the community for making page size a compile time known constant in the past. So with this result, he's like, it should have been a runtime known result, not compile time.
Better performance.
Kind of funny.
10% better in compiler benchmark. Another one is a simultaneous multi-processing allocator. It's a multi-threaded allocator with a lot of optimizations designed for release fast mode. Gotta go fast. Benchmarks are not showing much difference though. Nice one. In the standard library, we are getting support for Zig object notation files parsing, both at compile time via directly importing Zon files and at runtime using functions from the zon.parse namespace. Okay, that's basically all. I hope you enjoyed the video. If so, subscribe. I'm planning to make more of them.
And a round of applause for Morgan Freeman.
Yeah. I wanted to show one other one that Andrew Kelly gave recently. And it's a lightning talk.
Hi there. Let's check out what's waiting for us in the
Oh.
Python 3.14.
We got some autoplay. Here you go.
3 years ago, I delivered this talk about data-oriented design, which has
That's normal
been
speed.
fairly well received. In it, I mentioned my journey as a programmer, specifically getting unstuck from a skill plateau that plagued me for over a decade. I'm pleased to report that I didn't stop there.
Has everyone seen this talk that he's talking about? Yeah, so this is Practical DoD, also on his website. It's also on my GitHub. I put it on there. Popular. I love the little tags here. So yeah, this is it. It's on Vimeo. It's 46 minutes, I think. Yeah. But it talks about like the basics of optimization. You can see from the title here, title slide. Oops, don't start it. Okay. Let's refresh it. Yeah, you can see from this, it's talking about the relative speed of all the things your computer might do. And so you can tell everything up here is pretty fast, and stuff further down here is a lot slower. So if you have a bunch of kernel calls, you're going to have some very slow code, and there's things in between. You got your L3 read, your RAM. You know, if you miss and have to go to RAM, and yeah, kind of optimizing for this. He goes over a number of different techniques for making it. For using data-oriented design. He's actually referencing Mike Acton's talk, which kind of started a revival in data-oriented design, which is not really a new concept, as Mike Acton points out, but it's just kind of like going back to, I don't know, getting out of the object-oriented mentality. And
Or
so
I guess you could just call it.
there's a couple of specific tricks in here for reducing memory consumption. Probably the biggest pattern is, you know, you look at what data you have, and you try to say, well, like, what's the average? And so, hypothetical observation: 90% of monsters are not holding anything, and so maybe you have one that's in line, and then you can have some pointer or an index into some other buffer to store some extra data in the case that you need extra data, and that's used a lot in the Zig compiler, where yeah, you kind of have this separation where you're like, okay, if we're in a specific case where we need more data, then we're going to store it in some other buffer. But in the common case, we're going to store less data. You know, he talks about with the tokenizer, or here's the abstract syntax tree one. What they had was a giant union, and they had a whole bunch of different fields for a whole bunch of different things. And they had a similar thing for the tokenizer. The original one was 64 bytes each for each token, and they just had a ton of data, and then they had specific pieces of data, like if it was a string, they would parse the string in the tokenizer and store it in the token, and then if it was a number, they would parse it as a double and have that information. Whereas, yeah, the general idea is for all of that extra data, you can either compute it later when you actually need it, which is part of the strategy employed here, or you store it in some other buffer off to the side so that you don't need 64 bytes for every single thing, and you actually only use the bytes that you need for the average objects that you have. So it reduces memory consumption and can make a big difference in performance. So another cool thing he talks about is the multi-array list. Have people used that here or know what that is? The multi-array list is where, if I can actually get up my pen real quick, I might be able to draw. I just dropped it. Okay. This might work. It works. Okay, so a multi-array list, the idea is you have some struct, it's not steady. This is my handwriting font, it's pretty cool. Okay, in the mainline Zig tokenizer, they have a start index, and this is a U32. And then they have a tag, which is going to be some tag enum. I think you do commas. And then, and yeah, so this is actually the shape in the current Zig tokenizer of what a token looks like. And how this would typically be stored in memory is, let's get blocks in here. So this is 4 bytes. This is 1 byte. So let's say this is our tag, and the whites are our start index. So typically how you would store this is you can put them together, but when you do, you're gonna have 3 empty slots, which you can't use, because this padding is going to be inserted to allow for aligned loads. So this cannot be used. And then, where's my cursor? I lost my cursor. Hold on. It moved to another screen, and now I don't see it. Is it to the left? To the right? All right, well, the point is that your memory is going to be this repeated. And so you're going to have a bunch of stuff that's wasted. 3 bytes wasted per one of these items. The multi-array list, what it does is it separates these out. So this tag, can I hold control maybe? This tag is going to be in a separate buffer from these. Let me delete those. And so now these will be stored separately from this one. And you'll just have an index into each of these. You'll have 2 different pointers, and yeah, the starts are right here. So this is also a concept that's important to save save 3 bytes per element, trying to reduce the amount of memory that you use. And the reason why we want to reduce it is because of speed, of bandwidth issues. We want to stuff as many things as we can into a cache line because it's expensive to go all the way to RAM whenever we have to do it. But anytime you're streaming memory in, honestly. There was a teardown for Zen 5 that was very good from Number World. And in it, they talk about the memory bandwidth. So they say for the full chip on Zen 5 that they were testing, they could get 60 gigabytes per second into the CPU, which feels like a lot, but if you divide that by 16 cores, that's 3.75 gigabytes per core. If you divide it by a 5 gigahertz CPU clock, that means 0.75 bytes per cycle. Then it does a division by the 512-bit load, which you could do at once. And it says, okay, this is how many loads per cycle you can do, 0.0117. If you take the reciprocal of that, that's 85 cycles per 64-byte load. And given that you could do like 4 instructions per cycle, you need roughly 340 instructions per load in order to fully saturate the CPU. And this is for fully saturating all the cores simultaneously. So, in other words, you cannot get that much data into the CPU. You're able to do a lot more compute. Now, you can get a higher number than this if you're not saturating all cores at once. On my own test, I was able to get 11 gigabytes per second into a single core, but that doesn't help the equation that much. It's still relevant that the CPU is way, 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 way faster than memory. That's the basic idea here. So, anyways, I wanted to show this.
And today I bring new insights to share with you. Specifically, I've been evolving towards a programming style where the memory layout of long-lived objects involves all of the state collected into a single struct with a pointer depth of 1. In other words, the struct, which is the data model of the application, has arrays and hash maps in it, but the array elements, keys, and values are forbidden from themselves storing pointers. 3 separate benefits arise from this code of conduct. First, we have a more compact information encoder. This means applications consume less memory while running, but more importantly, information density increases CPU count.
Does everyone know why that's the case? Why it uses less memory? What is he talking about? What he's specifically saying is instead of using a 64-bit pointer, you can have a 32-bit index into an array. And having it be 32 bits instead of 64 bits, you have a savings of a factor of 2. Okay, that's what he's talking about.
Cache efficiency. Consider this intuitive example. Storing 32 Boolean flags with 1 byte each versus storing them all in one 32-bit integer. It's the exact same information, but depending on the storage strategy, it's either half a cache line or 1/16 of a cache line used up. Next, we have serialization. Pointers are ephemeral, expiring along the process they belong to. When they are eliminated from the data representation, the same in-memory layout can be used on disk and across the network. This makes serialization as trivial as a single write B syscall, and deserialization 2 read B calls followed by rebuilding denormalized data such as hash maps. Finally, we have memory matching.
Did everyone get that? People understand that? What he's talking about?
Go ahead and rephrase it. So
Sure.
is it just kind of a page fault thing because you have it stored there, you're not constantly going out and grabbing it?
So what he's saying is when you have a pointer-based structure, if you try to store that to disk, when you bring that back in, the pointers are not
There's a translation.
valid, right? There has to be a translation. So you can convert it to an index, but he's saying if you're already using an index into an array, then you can just do the syscall that says, here you go, operating system, please take this memory and write it to disk, and then it will. And getting it back is also one syscall. So that's what he's saying, because otherwise you would need the intermediate translation step where you say, okay, we can't store a pointer on the disk. We need to translate it to an index into an array, and then back if you want pointers when you come back in. So what he's arguing here is that you don't have to have that translation.
As we'll see in the upcoming code samples, every application of this technique means using big O1 allocations rather than big O(n). This is not only a convenient simplification for those of us using languages with manual memory management, but is fundamentally better suited for compute.
It's not how many allocations you do, but it's how many allocations you hold on to. So you still might resize an array, but you're just going to have one of them, and it's not going to be infinitely nested.
In general, since it produces less garbage. This is my open source music player project called Groove Basin. I've been rewriting it from Node.js to Zig, and I've been playing with the programming without pointers style as I've been doing it. And I've been having a lot of fun. So this is what it looks like. Let's queue up an album here so we can enjoy 100 milliseconds of music. Okay, just to give you an idea, all of this music database is stored in this 27 megabyte file called DB. That's also how it's stored in memory. And here I have this file, which represents all of the state. So it follows the rules that all of the pointers are right here. These fields is arrays and hash maps, but none of the elements, keys, and values themselves have pointers in them. And as a consequence, this file can be shared, and it is shared into the WebAssembly code. So it's compiled into WebAssembly, and it's also compiled onto the server. And if we look at the network tab here, and the WebSocket, we can see that the first message that got sent across was in fact a 27 megabyte message that exactly matches this. It just got sent the bytes straight over. And this is for, well, about 13,000 songs, which includes the data for these waveforms, by the way. So 13,000 song data, including these waveforms, because they're actually compressed with the quite okay audio format adapted for images. So shout outs to Dominic Zaluski. Let's take a look at the S-trace of this. So if I let this server run for just a minute, I can open that up. You can see where it reads the database file. And you can see that this opens the database file, and already we're closing it down here. So we only do two operations with this file. We read the header to get the lengths of the arrays, and then we do a readme to just yeet all of the bytes from disk into memory. And then again, those same bytes will just go straight into the WebAssembly.
Is everyone familiar with the technical term yeet? All right.
Method of transfer.
Yeah, it's a method of transport or transfer, yes.
It's like lightning. The USB 5.
Yeah.
Very fast.
Let's look at the first example that I put together for programming without pointers. In this example, I have this state struct, and here we have some clowns. And each clown has a scariness factor and a funniness factor. But they also have a name, and that name is the key in this table. Now the pointer that we're dealing with here is the name itself. So you can see that in this code where we're creating the clowns, we have to duplicate our keys, which are strings, in order to insert them into the data structure. And then likewise, when we deinitialize the data structure, we have to iterate over the data structure for each key before we can deinitialize the table there.
Okay. So if you didn't duplicate these, what would it do? Does anyone know?
Repeat the question. If it didn't
So
duplicate-
he's talking about how in order to insert these as keys, so these strings, this memory here has to be duplicated. So this is going to take this string, which is like compile time, and it's going to duplicate it. So this will actually allocate, using your general purpose allocator right here, this string. It will return you back the slice, so then he can store it into this clown's hash map. So what would happen if he didn't duplicate it? Or do the comments on YouTube, do they have an answer?
Is he freeing it?
In this block, he isn't. So you can see we have error defer. So if an error occurs when we put it in, then we will free this one. If an error occurs when we put this one in, then it will free this one. Otherwise, we are de-initing this state object, and this right here does free the individual key pointers, and then de-inits the overall structure. So the answer is, if you didn't duplicate this, if this was just a compile time known string, this would actually be in the binary, like in the read-only data of your source file. So yeah, you would be able to use it, but it would be, I mean, yeah, it would be a compile time known string. So it would not, you wouldn't be able to deallocate it. It would just always live in your source file. So.
There. And these pointers, the fact that they exist, will prevent those 3 benefits that I mentioned. But the code does run, so if I run this code, test passes, which makes sure we didn't mess up the destruction of the resources that we've created. Okay, but let's transform this into the programming without pointers style. How are we going to do that? Pause the video and answer the question right now. All right.
Okay. Any ideas? How can he transform this to not use nested pointers? So we're creating pointers, right? When we have that const dimples, const humpty, we're allocating a string, we're getting a slice to it, and then we're putting it in the hash map. It's okay if no one knows. We can just watch it.
Just gotta yeet the pointers out.
Just yeet the pointers out.
How are we going to get rid of the name pointer?
That's serial transfer, by the
Okay,
way.
answer is, of course, a string table. I don't want to bore you with all of the logic below this. Really just focus on how this part transforms, what we have inside of this state. It's really just one field that we're looking at with this one table. Okay? In the updated code, we have an array of bytes, which is our string contents, all smashed together. And we have now a table where we can intern strings. This gives us indexes into this array.
So I've done this a lot, where I'll just have an array list. I'll just put my strings in there, and then I'll tie the lifetime of the strings buffer with this hash map. And so now you just d-init the string bytes array list, d-init the hash map. That's a very nice way of doing it. It's way better than having nested pointers, as he's talking about. Although I haven't done the string table thing before. I feel like Andrew Kelly, he's kind of obsessed with interning, if everyone knows what that means.
Remind me, please.
So interning is where you have one copy of a string, or it actually can be anything, but it's typically a string. And so yeah, whenever you get some data in, you want to intern it and say, do we have that memory somewhere in my string interning ether? And then you can get back a pointer. And there are a couple nice things about it. Lua uses it in its default implementation, for example. But yeah, you can, if you want to do string equality, you just say, is the pointer equal to the pointer? Because you interned them, so by definition it has to be the same memory address. Whereas if you weren't doing interning, then you'd have to do a comparison of the fields, or in the case of a string, each byte, you'd have to check, is it the same? So that's interning.
In order to reference the names of things, if you have relatively small strings, which is often the case, then a null termination is actually a pretty efficient way to store this data. That means that we can go from, on a 64-bit platform, 16 bytes just to point to the string. Now we can use 4 bytes and index into this array list as our string references instead. So it's pretty compelling. And that's not even counting any bytes that you save from the interning itself. I'll go over this code a little bit, but just to show you that it also works, if we just run it, we can see we have no resource glitches, and everything gets deinitialized. Now, let's first look at deinitialization.
You don't have to write your own interning to use these strategies, but if you think it would be fun to do so, go ahead.
Because you can...
Why would zero terminated strings be more efficient for smaller strings? Wouldn't it be the opposite, because there'd be a lower percentage of null? Or is he not talking
It's
about
more efficient because a slice has a pointer and a length.
Oh, okay.
If it's null terminated, you don't need a length.
Right.
And in this case, you don't need a pointer, you can use a 4-byte index. And so you went from 16-byte slices down to a 4-byte index.
You can already see, I'm going to flip back between these really quick. The first one, we had to iterate over all the keys and free them individually. That's not a batch operation. Look at this. Now we're freeing all the string bytes at the same time. And we're freeing the string table. It's just 3 frees instead of 1 per key. So we can already...
And this strategy is pretty similar to what kind of allocator? Does anyone know that? There's a special kind of allocator that eliminates these individual deallocations. You can deallocate the whole thing at once.
Oh, Arena?
Arena. There you go.
Nice.
There you go.
You tell from this DNit. I'm already liking what I'm seeing here. This is gone, this is in, right? So what do? We took the pointer and we moved the state that was being pointed to into the root state struct. So we took all those bytes and just put them right on the state struct. This string table is just an index. So think about the fact that if we were going to serialize this data, we would send only the keys of this data structure, because the keys are all in a row, and only the values are all only in a row, and send only the string bytes. This is actually denormalized data that can be computed upon deserialization. So on serialization, you only send this information, and then on deserialization, you compute this information. This is just to support.
Did you guys understand that? He's just saying you can do interning when you have a list of strings. So
The fact that when you're creating these things, for example here, we want to compare a string literal with our data structure, and these adapters allow us to do that without creating unnecessary allocations. But at the end of the day, you can see our test code. I'll flip back and forth between that as well. So there's that first test code here. Actually, let's put it at the top. And then you can see original, new. The test code actually, the usage of this state structure actually becomes more convenient after we reformat it this way. So arguably, the programmability with this data structure is even more convenient. Okay.
So he shows you can have null terminated strings to save data. There's actually a cool technique that I use in my tokenizer here. Yes, I want to delete the window, please. And let's open up main. Okay, what is it called? Okay. One thing I actually do in my new tokenizer, which I hopefully release tomorrow, I have a keyword buffer where I actually put all of the strings together without spaces, and they can be overlapping. So you can see we have adder space, and this E is also used in air defer, and of course defer is a subset of that. We have error, which uses the last two characters of defer, and we have or else, which includes or and else, and this E is reused. I think you get the point.
How much gas did the traveling salesman use to construct that string?
So you are correct that in order to construct this string perfectly, it is equivalent to a traveling salesman problem. The specific problem, if you look it up, is called minimal common superstring, I believe. But you can use a heuristic algorithm, which I did. I actually just found some JavaScript and just pasted it into my console and pasted in the keywords, and it spit this out. So I didn't even have to write the code to do this, and it works. What's nice about this is less than 256 bytes, which means that it fits within 4 vectors. In AVX 512, we can look up in a 128 byte table at once, so of course we need 2. And in order to do keyword classification, what I do is I hash the value. Using the hash, I can look up in 2 separate tables, actually, just for convenience. It could be 1, but for 2 separate ones. Where does it start? Where does it end? And then I just unpack it in SIMD to do the classification. And so, yeah, this is another way you could do it. In this case, because I know that it's under 256 bytes, my start index and my length, of course, is a byte. And actually, that would be the minimum if you want to use the AVX 512, table lookup as well. So it kind of works out in that way. But that's another strategy that I use. Kind of fun.
That is really neat.
Okay, let's look at another example of how we can transform a state data structure that has nested pointers into one that is not. In this example, again, I have the state struct, which is mainly what I want you to focus on. And again, it's just one field that we're looking at here. So here we have
Sorry, I got
called
distracted.
diseases.
Let me go back a second.
The programmability with this data structure is even more convenient. Okay, let's look at another example of how we can transform a state data structure that has nested pointers into one that is not. In this example, again, I have the state struct, which is mainly what I want you to focus on. And again, it's just one field that we're looking at here. So here we have this field called diseases. It's an array list. Each disease has its own array list of locations, and in those locations finally terminated something that does not have any pointers. And in case you're confused why there's no asterisk and there's still a pointer, the point is that a array list is a pointer, right? That is referencing the elements of the array. So that counts. So, pause the video, tell me how you're going to make this no longer have a nested pointer. Go.
What do we think? All right, let's see.
The array of location, and it's so separate.
Yeah, that might be it.
Of course, the answer is just move the field over to here. Let's take a look at how that's going to look. That's it. We really just moved the field over to here. So now all of the locations, instead of having a separate array list for each disease, they're all now smashed together, just like the string table was. Except this time we're not inherting it. In the original, whereas we have this array list which is nested, instead of that data, we now have a new data type which only stores a integer offset and length into this array. By doing that, these are not pointers, these are integers, and we've reduced, again, we've reduced the size of things. So we no longer have the overhead of another allocation for every element. And again, you can see that in the dinit function. So the original dinit function needs to iterate over all the elements and free the nested arrays. However, the updated code does not need to do that.
So what's the downside of this?
Can I ask a clarifying question
go ahead.
before that?
Yeah.
What are the sizes of the L1, L2, L3 caches? How much are we working with? Because that's what we're trying to do, is we're trying to get this in the L1 cache, ideally, right? So how much space does our program have to work with?
So it depends on the CPU, of course.
Yes.
But typically, L1 cache for like all the cores would be like 1 megabyte. So divide that by like 16. And then L2, I think of it as being like 8. Divide that by 16, so half a megabyte. And then, yeah, the 64.
Okay, so we're down.
I think for the biggest one, yeah.
We're down in
There's a way I can check.
double-digit megabytes. Is the scale of what we're working with. Okay.
That might be it. This is ghosty. Permission denied.
Sudo.
Okay. So I have all my devices on here. Can we grep for L1 or something? Okay. So that's a handler. Can I try something else?
Control F.
Do I have Control F?
Oh, does Ghost do not have that yet?
I'm not sure. Is there a button I can press to figure out the keybinds? I know there is. Let me see. I don't know. Let me try one more. Yeah, LSCPU is what I was expecting.
Okay.
Let's do that. Here you go. So L1D, I have 576 kilobytes, 12 instances. I have 12 cores.
Okay.
And then I have I, 384 kilobytes. Does anyone know what those are? What's the difference between D and I?
8 letters.
Say it again?
Is it data and instructions?
Yep, there you go. Data and instructions. So they're separate caches for those. And then L2, I believe, is just shared. And so, yeah, 12 megabytes, 12 instances of that. And then you have L3, 2 instances. So L3 is actually shared. Half the cores and half the cores have an L3.
Are you on the game?
Yeah,
Yeah.
that would be why. It has to do with how they stitch their cores together, I believe. So
Intel has different it's not shared.
Mm-hmm. Yep.
So the moral of the story is, if you reasonably believe that you can fit an important piece of data that's going to be operated on frequently, or at the same time as some process within some fraction of a megabyte, then if you can do it, then
Half a
you can.
megabyte, yeah.
Well,
Yeah.
varying on the CPU, it's
Mhm.
something measured in hundreds of kilobytes.
Mm-hmm.
If you have data that can be scaled down to hundreds of kilobytes, and you can do it pointer free, then you can make that execution potentially literally 10 times faster or more. Or that was a logarithmic scale that we saw before? Was that
Yeah,
right?
so the L1 cache it's like 3 or 4 cycles, L2 in more like the 10 range, L3 is going to be like 100.
And RAM.
That those are the general rules of thumb that I remember.
So we realistically can have
Yeah,
these
the-
operations 100 times faster-ish, 50 times faster.
Yeah, the idea with the caches, the reason why we have the hierarchy, is each one is going to be an order of magnitude smaller and an order of magnitude faster if you go in that direction, or the reverse, you're making it an order of magnitude bigger, but it's going to be slower.
Okay.
And the reason why is because of physics, right? So if I have something that's this big and it has to get to a point right under it, then the distance it has to travel is a lot smaller than if I make it this big. Now the distance is a lot larger. So for the same process node technology, if you make it bigger, it will have to travel a longer distance, which takes more time.
But since it's smaller, transport is less expensive too.
Yeah. So, all right, we got like 5 seconds left.
We hope to see you.
Yeah, thanks for coming.
Thank you, Niles.
Freeze all of them with one unit because they're on the root state struct. And let's take a look at the
Oh yeah, I wanted to ask. So, what's the drawback of this strategy?
It's not infinitely extensible. You have to know discretely upfront what you're dealing with.
Yeah. So you might want to add something to the first array, but you have multiple. How are you going to do that? Well, you'd have to move all that data out of the way. It would be very expensive. So yeah.
If it's sparse, maybe a different algorithm that's actually
Yep.
better to use.
Yeah, you could use sparse, but you could waste data unless you're really smart about how you do sparse.
the init function. So the original init function needs to iterate over all the elements and free the nested arrays. However, the updated code does not need to do that. It frees all of them with one unit because they're on the root state struct. And let's take a look at the usage code. So in the first usage code here, we can see that we first have to add to the main array, and then we need to hang on to that reference and then append to the nested array. And so we do that for these two things. However, in the updated code, again, it actually becomes a little more convenient to program in this new style. It's not bad. It's not a bad transformation. Instead, we can use the append. We don't need to keep a reference because we can use a helper method to add our location slice, which can then just be copied right into that value. And at the end of the day, we end up with the same data in memory, just in a more compact encoding that can be transferred to disk or across the network. And just to show you that they both work, you can run the first one, we don't have any leaks or anything, and the second one, of course, is equivalent. Well, I'm out of time to discuss the remaining tidbits, such as how this style of programming comes full circle by bringing garbage collection back into the picture, or various tricks to achieve integer type safety. I'll leave you with the knowledge that I've written an entire WebAssembly linker in this manner, and I plan to give ELF the same treatment. I'm in the midst of finding out how well this scales as the complexity of the task grows, and I'll be happy to report my findings later. See ya!
So I want to show a piece of code where I do something kind of like this. It is kind of near the top. I don't remember what it's called. Yeah. So I made a len aligned buffer, and this is just a struct that wraps an alignment, and in this case, the length is aligned as well as the pointer. And I actually don't need to do this for the main thing in the tokenizer now. Originally, what I was going to use this for is I'm like, okay, when we allocate a source file in, we want to make sure the length is a multiple of 64 because I'm pulling out 64 bytes at a time. But actually, I realized as long as the pointer is aligned, you can't have a page fault if you read past the end of the length of the slice. And then we can also just delete that data by producing a mask, which is very easy to do. We just say how much length is left, 1 shift to the left by that, subtract 1. There's actually an instruction, BZ high, to do this on x86, so you don't even need to do all those steps. And so anyways, I have this. Okay, so in my test bench, I want to read in all of the files. If infix test is false, which usually I leave it as that, it looks at all the files inside of this directory, files to parse. And for now, I actually open up 2 iterators, which maybe I don't have to do that. But anyways, what's cool is I have this sources right here, and I set it to be empty. This is the new syntax. Let's see if I can go to definition. Look at that. So this is going to set my source list, my path buffer, my number of bytes, and my number of lines, which I want to track for the files. Sets them to 0. And my source list is sourcelist.slice. So this is the multi-array list I was talking about, where these fields will go into separate parts of an array allocation, but these can be different sizes. So this len aligned buffer, it has the alignment, or actually that's a compile time thing. The fields of it are a pointer and a length. So it just has a pointer and a length that will be stored separately from this path. I don't remember why that was necessary off the top of my head. But anyways, what's cool is I set it to be empty, and then I say if we have an error, deinitialize it. Every time you allocate some memory, you want to potentially deinitialize it. But this didn't actually allocate any memory except on the stack. And the reason why I do this actually is because immediately after I have this defer where I'll make the source list a to-owned slice. So this is taking the multi-array list and it's giving me ownership. So this just takes the slice and returns it. Slice, it just holds the pointers. I don't know. But this type is the one that I want. It's more efficient to access it, whatever. And then for the path buffer, this holds all of the path strings. So this is similar to what we were talking about. I get the allocated slice. If you use to owned slice, like path buffer to owned slice, it will remap the memory and potentially memcopy it. And I'm like, well, I don't need to do that. I'm not even going to use this allocation for that long. So just give me the allocated slice. I'll own it. And I own pointers into this buffer. And then I can just delete the buffer when I'm done. So yeah, what's cool about this is I construct the source list and the path buffer in here. And at the end of it, so you can see I append a slice into path buffer with the path string. And then what was the other one? I'm sorry. Source list. Right here. So I can append what is the path and then what are the file contents. So this actually reads in the file. And I'm just organizing this data. And yeah, so at the end of this, we're going to run this defer. Whether there's an error or not, we run this. And so then this error defer will be tripped if there was an error. And so this will properly deallocate it. So this saves me from having to have like multiple different ways that it could be deallocated. Yeah, whereas with this, the thing that I do on the happy path, I just say, just make sure that this happens, and then this happens if we hit an error. So if we hit an error right here, or right here, or right here, any of these errors, then we're going to come up, we're still going to hit this code before we run this dinit. So this simplifies the deinitialization that I need. So you might, I don't know if anyone got that, but also one interesting thing I did with this, file contents, when I read the file in, I have this error defer here, but I put this comment in, the compiler should be able to deduce that no errors can occur underneath this. I actually didn't check the assembly for this yet, but to append it into the source list, I already made space up here. I actually manually managed the capacity here because I didn't want to use the way they were doing the growth. But that's neither here nor there. The point is, I made it so that after we read in the file, it's not possible to have an error in here. And so that means that this should hopefully be eliminated, where we don't have to give back the file contents, so long as that operation itself was successful right here. So
if the space is available, it's not going to error out.
mhm.
I mean, theoretically, it could error if you don't have enough space.
Yeah. So yeah, it's going to be a less dumb error. Like, so if you allocated the file and then for some reason you had an error here where you're like, oh, we ran out of memory here. To me, it was like, okay, well, we read in the file for no reason. So anyways, just did it that way. And that was kind of an interesting piece of code. I think I might have had one more thing to say, but I also do this. This is kind of what I was showing with my intro to SIMD talk, where I wrapped this in a len aligned buffer. So I know that the length of this is aligned, and I know that by definition of this struct here, we put zeros in at the end. And so because I know that, I want to add these together. Adding zeros is perfectly fine. It doesn't affect my result. And so rounding up to the nearest, the next multiple of 64 with a length allows this to be SIMDized by the compiler very easily. I actually think, yeah, I actually made it so this will return a vector. This will return a vector. We do linevex plus the vector. We reduce the vector by adding these up, and we know that it won't overflow because that would mean you used more memory than a pointer can hold. So that doesn't make sense. So anyways, that was that pattern. And let me go back. Okay, one other thing I wanted to show were on Zigit.
Do you have any animations in this presentation?
I don't, I'm sorry. I took AJ's advice. I did not spend 2 months on this presentation, but for the next one I will.
Oh, excellent. So I'll work you out for 2 months then.
There you go. Yeah, I wanted to show Zig patterns real quick. The thing that Andrew Kelly mentioned, this is a really big deal. Enum index. Okay. Let me get rid of the transparency here. So you have an enum, you have this underscore here. That means that it is a non-exhaustive enum, I believe it's called. I want to make sure I don't get my wires crossed on that. Okay, I don't know why I doubt myself. It's a non-exhaustive enum. And what that means is that any number is accepted as a valid instance of this enum. Any U8 is a valid instance of this. And what this can be good for is basically you get nominal typing for integers. So let's say that you're doing some strategy where you say, okay, I'm going to use an index into this array. What you can do is you can declare a nominal integer type using this feature and say, okay, this is a token index. It's indexing into my tokens array. Or this is a path index. And so what this means is you can make a function inside of this or inside of some other struct that you're interested in. And you can say, okay, it has to take in an index that nominally has this type. So you can get an integer that is bound to a certain usage. So you cannot actually accidentally pass a different index that's an index to, let's say, a node index being passed in as a token index. These are two different numbers that mean completely different things. They refer to different arrays. So you can get nominal typing on integers using this feature. And I thought that would be really cool for people to know about if you haven't heard about it. So this is a very important feature in the block that they have right here. It's, yeah, they have some good stuff here. Do we have a archive 2024? Okay, yeah. Andrew Kelly said, lately my Zig code has started to look like this in all of my projects. He has a whole bunch of U32s with a nominal, with a name. These are named U32s. So they can only be used for the specific thing that you want them to be used for. So this can help improve the safety of using an integer as an index when you want to make sure it doesn't go into the wrong array. So.
It's okay. You know, he figured it out eventually.
Yeah.
Joking, because Go, that's been a pattern in Go for a while.
Well, there you go. Now you have it in Zig.
Can't you just use a bunch of typed out since
You could, but aren't it's not checked, right? Like, yeah, you can say like, oh, I'm defining this other word to mean a uint32, but it's not going to be checked, and you can't do compile time type reflection. Certainly not with the macro system, at least not that I would know of. But yeah, so that's pretty much it. There are some more patterns here if we want to look at any of them, but we can call it right now.
We are all now Zig 0.14 experts.
There you go.
Good job.
All right. So next month, does anybody want to give an introduction to Zig?
Well, Andrew Gossage is talking next month.
Oh, he is. Let me, okay.
It might even be introduction as well.
No, he's doing, I'm actually quite excited for this one. He's doing web dev, writing APIs in Zig. So I'm quite interested in that one because I would like to see what the state of that is and potentially be able to do it. So that's a good one. Okay, but next month, the month after that gives you 2 months to work on your next presentation.
Yep.
But we don't have to squish you in. Does anybody got?
Does anyone else want to present?
What's he using as a web server for his API? Do you know?
I don't know. I don't know what he's going to present. I'm going to be as surprised as everyone else. And delighted. All right, boom. And I just announced it. And I'll post it in the meetup so that I don't forget, or not the meetup, Okay, cool. Anyway, yeah. So do we have any particular topics of interest? Anything that people want to learn about? And do we have any topics that something that you've learned about that you're interested in or excited about and would love to share?
Working on anything cool?
Nothing that I know I'm going to be done with the next couple of months.
Well, vaporware is invisible to us here. We can't check it while you're giving the talk. So if you're like, well, it works enough to show a little bit.
Yeah. Just someone to take a little bit of the load off of Niles so that he's not a full-time Utah Zig presenter.
Yeah, I mean, I'm fine with it.
I
But
can do something then, I guess.
Yeah. Okay. So, what's your handle in the Zig Discord?
We just NGOFX.
NGOFX. So
I'm on there, let's see.
next month, so this is April, so next month is May.
That checks out.
All right, so that would be the following month.
June.
We are getting good. We are getting good.
I know, we're
gonna
dialed
put
in.
that into a bit mass.
Yeah.
Mass rapid, overlapping with figures on the months.
Yep.
Alright.
Can figure out why the October, November, and December are the 9th, 10th, and 11th months.
We know this. It's because someone got beheaded,
Okay.
I think. Because each Roman emperor had to have his month be the longest, and then they had to, insert some more in the middle, and because Augustus, So I think it was Julius and Augustus didn't want they wanted to be in the summer, not in the winter. I think that's what it was. Is that not what it was?
I don't know, but that is fun.
It's a political thing because Julius and Augustus, because those are the 2 months that go 31 days in order. July has 31 days and August has 31 days, right? Because normally it alternates 30 and 31, but those two go back to because I think the one didn't want to disrespect the other, but then also didn't want to have fewer days in his month. That's the story I was told as a child.
Well, I guess I'm glad we're past that. I wish we just made all the months have the same number of days and then have one left over.
So so New Year's Day, right?
Yeah.
So you'd have 13 months that are 28 days long with a New Year's Day and a leap day as holidays.
There you go.
That would throw some real. That would be religiously problematic, though.
Why is that?
Well,
There isn't
because
13th.
because God commanded rest on the seventh day, and although it would make a lot of sense to, I don't know. I think that if we did it, I bet that a number of churches could get behind like calling it Day of Jubilee or something like that, and just having it be another Sunday. So you'd have 2 Sundays back to back.
Oh,
and
yeah,
one would be
yeah,
a
yeah.
Sunday of Jubilee, because there is a biblical tradition of Jubilee. But,
Right.
But I think that's part of the reason is because the 7-day week has taken hold as Christianity. And I think there's other religions that do the 7-day week as well.
I think in the French Revolution, when they were trying to modernize and get rid of religion and stuff, and a lot of the structures, they tried doing a 10-day week to make it even in metric and a new calendar, and it didn't work because the weekends were too far apart. People didn't get enough rest.
So yeah, I mean, for how much shade people might want to throw on the Bible, there is ancient wisdom there that has survived for tens of thousands of years, 10,000 years, whatever, for good reason. Well, I guess not 10,000 years, but the traditions that predate it, that it absorbs.
Well, 7 got religious significance, right? Because that was the number of visible celestial objects to the naked eye, right?
Maybe. I don't know. But I do believe, and I could be wrong about this, it's pure speculation, but I do believe that there's something about a cycle of 7 days that we do need a weekend. And in olden times it was 6 days of work and 7 days rest. Now we have 2 days of rest. But I think that there is something, like you were saying about the 10 days, there's something in that range that
Work was also different back then. They'd work 6 days and then have one off. It wasn't the invention of clocks in factories and having visible time where managers wanted okay, you have to work exactly 8 hours. Before that, people took a lot more breaks and were a lot more flexible with time, and weren't as productive on an hour-to-hour, day-to-day basis.
Are we as productive on an hour-to-hour basis?
I have seen some articles claiming, at least I saw the headline where they're the average person works more than a medieval peasant.
Yeah.
So,
Plus, now that we're using MCP and our chat GPTs, get way more stuff done.
Yeah. All right, well, I'm going to go ahead and turn off the online so that we can get into the dangerous conversations.
Yeah. There you
So,
go.
adios, suckers online. Now we're going to get rude up in here. Everybody ready to burp and fart?